Hello everyone, today I'll be talking about PFAS, also known as forever chemicals. These chemicals are found in many everyday products and have become a major environmental and health concern around the world. In this presentation, I will explain what PFAS are, how their chemistry works, where they are found, and why scientists are concerned about their effects on people and the environment. What are PFAS? PFAS stands for per and polyfluoroalkyl substances. These are man-made chemicals that were first developed in the 1940s. Companies began using PFAS because they are resistant to water, grease, oil, and heat. There are thousands of different PFAS chemicals, but some common examples are PFOA and PFOS. PFAS are called forever chemicals because they do not easily break down in nature. They can remain in the environment for many years or even decades. This is mainly because they contain very strong carbon-fluorine bonds, which are extremely difficult to break down. Everyday products containing PFAS are found in many products that people use every day. Some examples include non-stick cookware, waterproof clothing, food packaging, stain-resistant carpets, firefighting foam, and cosmetics. Companies use PFAS because these chemicals help products resist stains, grease, and moisture. For example, non-stick pans use PFAS coatings to prevent food from sticking during cooking. The problem is that PFAS can slowly leak from these products into the environment. Once released, they can contaminate soil, water, and even the air. The chemistry behind PFAS. The chemistry of PFAS is what makes these chemicals both useful and dangerous. PFAS molecules contain carbon atoms bonded to fluorine atoms. The carbon-fluorine bond is one of the strongest bonds in organic chemistry. Because of this strong bond, PFAS are highly stable. They resist heat, water, and chemical reactions. The stability allows products containing PFAS to last a long time. However, the same stability also means that PFAS do not naturally break down easily. This allows them to build up in the environment over time. How PFAS enter the environment. PFAS can enter the environment in several ways. Factories may release PFAS waste into rivers or groundwater. Firefighting foam used at airports and military bases can also spread PFAS contamination. Landfills and wastewater systems may release PFAS as products break down over time. Once PFAS enter water systems, they can travel long distances. Scientists have found PFAS contaminations in rivers, oceans, rainwater, wildlife, and drinking water around the world. PFAS can also build up in living organisms through a process called bioaccumulation. This means the chemicals stay inside the body instead of leaving naturally. Health effects of PFAS exposure. Scientists are still studying the health effects of PFAS exposure, but research suggests there may be several risks associated with long-term exposure. Possible health effects include liver damage, hormone disruption, weakened immune system, thyroid disease, developmental problems in children, and increased cancer risk. People are often exposed to PFAS through contaminated drinking water, food, or consumer products. Since PFAS can remain in the body for long periods, scientists are concerned about the effects of continuous exposure over time. PFAS in drinking water. One major concern in PFAS contamination in drinking water. Many communities near factories, airports, and military bases have discovered PFAS in their local water supplies. Removing PFAS from drinking water is difficult because normal water treatment systems cannot fully break down these chemicals. Even small amounts can remain in the water. Because of growing concerns, government agencies such as Environmental Protection Agency are creating stricter regulations to limit PFAS contamination and protect public health. Methods used to remove PFAS, scientists and engineers are working on ways to remove PFAS from contaminated water. Some common methods include activated carbon filters, reverse osmosis systems, and ion exchange technology. Although these systems can reduce PFAS levels, they are expensive and may not remove every type of PFAS completely. Researchers are also studying new methods that could destroy PFAS chemicals instead of simply filtering them out. Future concerns and solutions. In the future, scientists hope to reduce PFAS pollution by creating safer alternatives and improving environmental regulations. Many companies are beginning to reduce the use of certain PFAS chemicals in their products. Chemists also play an important role in developing new materials that are safer for both humans and the environment. Increasing public awareness is important because many people do not realize how common PFAS are in daily life. In conclusion, PFAS are synthetic chemicals used in many everyday products because of their resistance to heat, grease, and water. Their strong carbon-fluorine bonds make them highly stable and difficult to break down. Although PFAS are useful, they can also create serious environmental and health concerns. Because they remain in the environment for long periods of time, PFAS show how chemistry can improve modern products while also creating challenges that scientists must continue studying and solving. Thank you for listening.